Hey guys, a while back I made a video explaining the difference between 2-wire, 3-wire, and 4-wire CPU fans and how to control them using an Arduino. One of my viewers brought up a very interesting comment. He said that many of these 4-wire CPU fans, per the information provided on the internet, require high-speed PWM, and the Arduino, by default, produces low-speed PWM. And what I mean by that is the Arduino on certain channels puts out about 490 Hertz PWM frequency, and on others 980. And these fans, according to the literature on the internet, require about 25 kilohertz, so quite a big jump from what the Arduino puts out. Fortunately, the Arduino can be reconfigured to produce high frequency PWM, and I'll show you how to do that in this video. And then I thought we'd do a little experiment to show PWM control of this fan right here using the default Arduino settings and the high-speed PWM settings.
The wiring for the fan is pretty simple. First, take the red and black wire, hook it up to your 12-volt power supply. The blue wire will go to Arduino pin 9, and the yellow wire will go to Arduino pin 2 with a 10 kilo ohm pull-up resistor. Also, it's very important that you connect ground on the Arduino to the 0 volt on your power supply. For the first part of the experiment, we will use the Arduino in the default settings, which means that for Arduino pin 9, we will output about 490 Hertz PWM frequency. This fan produces 2 pulses on the yellow wire for every revolution. So we're going to use digital pin 2 on the Arduino to act as an interrupt to launch the subroutine counter, which will simply keep track of those pulses. Under the default settings, the Arduino will have a maximum PWM value of 255. By incrementing in blocks of 51, we can achieve 0%, 20%, 40%, 60%, 80%, and 100% PWM signals going to the fan. We will send that PWM value to the fan using the analog write command, and then wait 5 seconds for the fan speed to stabilize. After that 5-second wait, we will reset the count to 0, and we will count how many pulses occur in a 1-second period. Now, in order to convert that number of pulses to RPM, we would multiply by 60 and divide by 2, or we can simply multiply by 30. Then we'll write those values to the serial monitor and see what happens.
I've got the fan and Arduino connected per the diagram, and over here I'll be powering it with 12 volts from my power supply.
Let's go ahead and run the serial monitor and see what happens. Okay, our first reading at 0% PWM, we get 750 RPM. Looks like about the same at 20%. 40%, we move up to 1170 RPM. 60%, 1740. 80% around 2400. 100% 2880. So it seems to be tracking about as expected. In order to explain the high frequency PWM code, I've laid it right next to the other code. In this code, we'll still be using pin 9, but instead of 490 Hertz, we will be outputting a much faster 25 kilohertz PWM. So these first 4 lines are essentially the same. You will notice that the setup sections are quite different. All of this code right here is used to reconfigure pins 9 and 10 on the Arduino for high PWM output. In order to get 25 kilohertz, however, we have to set the maximum PWM value to 320 instead of 255. Instead of analog output commands, we use these commands instead to set the PWM values for pins 9 and 10. The main loops are essentially the same, except that we're using a value of 320 instead of 255 and a value of 64 instead of 51. We're also using this command to set the PWM value instead of the typical analog write command. Now let's run it with the 25 kilohertz PWM. Looks like our first reading is about the same. as is the second. %, 1170 RPM. 60%, 1770. 80%, 2400. 100%, 2880.
So at least in the case of my particular CPU fan, high-speed PWM control was not required. Now that may be different with your fans, you'll just have to test it out and see. Now keep your eye out for this fan in a future video. I have plans to make a new and improved Arduino hovercraft. As always, thanks for watching.